Welcome, everybody. I was about to say welcome to the first webinar of the year, but I'm pretty sure it's nearly July, which means it's not the first one of the year. It's my first one for a while because we've been pretty busy with some interesting projects, which we will talk about in a few moments. So to those of you who are new to the webinar, welcome. It is called WTF Cloud Native, so we do occasionally swear, but even we get a bit tired of the F word. I am joined today by my colleagues from Container Solutions, Teresa and Carla. You want to say hi, ladies?
Hello.
Hello.
Good afternoon.
And Julian and Emin, who will be joining me for the gossip. You want to say hello, guys?
Hello.
And of course, our special guest today is Julie Gunderson. Hey, Julie, how are you today?
I'm great. Glad to be here.
And you were telling me it's 9 o'clock in the morning where you are.
It is because I'm in Boise, Idaho. So it's 9 a.m. So only coffee for me right now.
Right. I was just saying earlier, it's very hot in England right now. What's the temperature like where you are?
So it's been raining for the last 2 weeks. It's going to get up to 80. I can't do Celsius conversions.
Yeah.
It's warm, but not hot.
We were going to say 80 Fahrenheit. We don't know what that means in Europe. That doesn't mean anything to us. Okay, fine. So later on, Julie is going to be talking about reliability and how to get there. Today's format is slightly different. It's going to be more like a lecture because we don't have time this time for questions and answers at the end. So that's the format today, slightly different from our usual format, but I still think it's going to be a lot of fun. Before we get into the content, before Julie comes on, of course, she's our guest of honor today. We do have a few things to discuss, or a few things to announce. The first one is, of course, housekeeping. As you all know, we do have a strict code of conduct that we do enforce. I won't go into the details here, but one of my colleagues will share the link to our code of conduct in the chat box. If you're running events, physical or virtual, you can use our code of conduct. It's open source. We don't care if you use it. And it talks about what is tolerated and what's not tolerated. And of course, we will enforce that, so be mindful of that. We are recording today. We record our webinars for many reasons, for people who can't join the webinar at this given moment, but also for people in locations where the bandwidth is not large enough for people to watch streams live, then they can watch back later. If you have a real problem with the recording, let us know and we can black your face out if you ask questions. We can't completely erase you. So if you're very sensitive to that, then of course it's probably best you drop off. But if you let us know if you'd prefer not to be on the screen, then we will blank you out later when we release this. More housekeeping, Teresa. I always forget something. Did I forget anything?
No, you didn't forget anything today.
Well, we're getting good. We're getting good. Okay. For those of you who have never been into one of our webinars, by the way, we always follow a similar structure, which is the housekeeping announcements, some extra announcements, and then we have a session on industry gossip. And this is basically the warm-up act for the main act. So after the announcements in a second, we're going to do a little bit of gossip, which is usually fun, although we have two newbies today. And I don't know if they're nervous, and we're going to find out later. If you want to sign up to our amazing content, you can scan this QR code and hit the subscribe button. I was really unhappy the other day on Twitter because some extra mails had gone to some people, and we're actually really proud that we don't spam people with marketing content. If you subscribe, you can click you're looking for a job, but you don't have to. You can click you're interested in our sales, but you don't have to. Click the boxes that you'd like us to contact you on. And it's quite easy to unsubscribe from our newsletters. So as I said, we are proud that we don't spam the community. And so we were all a little bit upset when actually we got some reports that maybe we miscued a few weeks ago. We do take this really, really seriously. And the content's good. It includes our webinars, it includes a regular newsletter, but importantly, it also tells you when our next conferences are coming up. And our conferences are a lot of fun and pretty educational. And, you know, of all the people in the world who are trying to make virtual conferences feel a bit like real life, I'm afraid to say that we're the only ones who have actually done it. So keep your eye out for our events as well. Speaking of which, we will be doing a physical event in Amsterdam soon. It's going to be the 10th anniversary of DevOps Days. Now, some of you may or may not know, but DevOps itself was actually started, or at least in the Netherlands and in Belgium, where Chris is from, who was one of the creators of DevOps, the DevOps movement. Actually, a lot of it was sort of invented or cooked up in Amsterdam or down there in Belgium. So there's a very, very strong community in the Netherlands. Our colleagues will be will be there. We'll be on our booth. Tim promised to be wearing some fancy clothes. I don't know if he's here today. And he said he was going to set his hair on fire. I'm not sure why he's going to do that. But what that means is you'll definitely be able to find the Container Solutions team. They will do all kinds of things. They will answer questions about cloud native till the cows come home. So if you want some free consulting, go and speak to them and you'll get it. They'll tell you what it's like to work at Container Solutions if you're interested in a job, and they'll have lots of money on their expense accounts for booze and other drinks and lots of fun. So please do say hello. And if you are umming and ahhing about going to DevOps Days, it's a really nice conference. Not commercial. I wouldn't say that unless it was true. Nice conference in a nice location, and it's probably going to be very sunny on that day. All right, the big news from us. Now, I don't always drink on the webinars, just sometimes, and I am going to drink today, even though it's 9 o'clock where Julie is, and that's because, oh yeah, that's a special noise, that. That's because Container Solutions, cheers everybody, Container Solutions closed an investment round with a company called GCP, not Google Cloud, not Google Cloud, don't get confused, Growth Capital Partners. We got bashed in the pandemic, of course we did. We got battered around. We had problems with cash flow at one point. We had problems with our sales pipeline. And most importantly, and most urgently, we of course had to try to work together while stuck in our houses. We needed to support each other and support each other's mental health and mental well-being. When I tell you it was a tough 2 years for us, it's true. But we stuck to the task at hand. The team at Container Solutions have been fantastic. Work had to be done, sometimes difficult work. We were creative, we were tenacious. The greatest sort of part of my career was trying to steer this group through the last couple of years. And what a group to be able to work with to do that. The net result of that is that we've had some extraordinary business results. And based on all of that, last year, we went looking for a private equity firm who shared some of our values, who wanted to build a professional services firm in the same mold that we were building ours in, who shared our values of safety, risk-taking, innovation, etc., etc. And we found that partner. So what does it mean practically? Practically, it just means we're going to do more of the stuff that we love, more awesome content, more awesome community work. We'll be able to better serve our customers by, building our team probably a little bit quicker than we usually would have done. So really, really big news for the team at Container Solutions, and I think something worth celebrating for us all. We are hiring, we're always hiring, but specifically right now, we're looking for people to help us around resource management. So this is as we build up our operations team, and we're always looking for talented cloud native engineers. What does that actually mean? It kind of means things like Kubernetes, containers, re-engineering applications, occasionally refactoring application code and stuff like that. It's a very broad role, and all different cloud native engineers have got different specialities. So it's a really nice role. It's the key role at Container Solutions. It's the main thing we do. So if you want to come and work at a cool company that does loads of cool stuff with cool customers, you can check out our careers page there. And on that note, speaking of our company and all the nice things we like to get up to, gossip is one of them. We do love a little bit of industry gossip. And today we're going to be talking about the one key to rule them all. I don't even know what this means. I'm so old. I don't really understand what any of this means anymore. And what it does is zombie attack. Now, I know something about zombies because I was raised in the 80s and there's a lot of zombie movies then. So who's taking the first one? Is that Julian?
Or is that the first one? Yep.
Yeah, Julian. Okay, welcome, Julian. What's it like to be on your first What the Fucking Are?
Thank you. Yeah, that's great. I feel great. I'm pretty new even in CS, so I'm pretty happy to have a lot of exciting things happening.
And have you got a branded T-shirt on?
This is I asked for this one for the last SRE conference.
Very good, very good. So I've actually got, I don't even know what I'm wearing. Usually I accidentally put on another company's T-shirt. Well, okay, so welcome, of course, welcome to Container Solutions. You said you're new here, and welcome to the webinar. So take it away, tell us what's been happening.
Sure, so the Only Key Duo was a Kickstarter project that started last year, and it actually got through, and you can now buy it on the internet. What is it? So the one to rule them all. It's the one security key to rule them all, because it's a security key that does hardware password manager, but not only. It's also You can also store your FIDO2 key, your TOTP keys, Yubico OTP keys, SSH keys, OpenPGP keys, and many more things. So this project started as a few years ago in 2015, I think, with a key that was a bit bigger, like a USB key. And nowadays, the Duo that just came out is more like a very small YubiKey Nano also. And yeah, it's basically a YubiKey Nano on steroids. You can store a lot of things on it. You don't need to remember any password ever with this. And you also have a sysadmin mod that allows you to do like rubber ducky attacks type. So if you really want to. But yeah,
What is a rubber ducky attack? You've got to tell us what that is.
Injection attacks. Rubber ducky is just, you can plug with the sysadmin mod. What you can do is actually you can just plug it in a computer and open a terminal and type commands. So you could actually spread malware with this, but the main point is not this. The main point is to store your passwords and also everything that can help you get into accounts.
Very cool. Okay, and now do we have any links to share with people if they're interested in following up on this story?
I think it's already, yes, the link is already in the chat.
Right, so if you'd like to learn more about that, the links are in the chat box. And yeah, you can follow. So thank you, Julian. And brilliant to have you here today.
Thank you.
Okay, Evan, over to you.
Hey everyone. So this is not an actual gossip. It's just a fact, actually. So if you look at the AWS service terms, it's not a new thing, actually. It's been a while since it's added to the service terms. If you look at the section 42.10, you'll see there is this sentence. I'll just read the sentence. So this restriction will not apply in the event of the occurrence of a widespread of a viral infection transmitted via bites or contact with bodily fluids that causes human corpses to reanimate and seek to consume living human flesh, blood, brain, or nerve tissue, blah, blah. So it's saying, so AWS service terms may not apply in case of a zombie attack. So it's just, you shouldn't expect to, work on AWS in case of a zombie attack. So you should just run for your lives, it's just.
You've got to send me those terms. You've got to send me those terms. I mean, I know that AWS are thorough, but I didn't know they were, avoiding liability should the zombie apocalypse actually occur. Yeah. And by the way, do they know something that we don't? Is there likely to be a zombie apocalypse?
That's the question I've always had in my mind when I first saw this section. The link for the service terms of AWS is in the chat right now, and you can just go to the 42.10.
I'm gonna do what all good leaders do. I'm gonna steal this story and tweet it as if it was my own. Yeah, that's what I'm about to do right now. So this is awesome. You say this is not gossip. Well, just a fact. This is one of the funniest things I've ever heard on our What the Fuck is the Goss section. So there you go. You heard it here, folks. First, AWS will not cover you if there is a zombie apocalypse. So, wow. I think I would like to work with a cloud provider who does protect me in the event of a zombie apocalypse.
You should just run for your life if there's a zombie attack. You should just try to work on cloud providers in case of a zombie attack.
I live in central London. There's a zombie attack every Saturday night. on that note, I will now stop sharing my screen, and I think we are going to give a warm WTF/Container Solutions welcome to Julie Gunderson. So Julie, I do believe this is your first time working with us on a webinar. Is that correct?
It is. And am I sharing my screen correctly? Because my child stole my office. So he has me set up on his gaming computer right now, so that you didn't have to have a webinar from my kitchen. And I'm not sure, can you see my screen?
We can see your screen.
I'm really excited to be here. I just have to say, on the zombie apocalypse side, one of my favorite books is, and I was trying to get the link, but I can't multitask, is The Zombie Survival Guide by Max Brooks. Excellent book. It gives really practical tips on how to survive a zombie apocalypse, such as cut off their head before they can cut off yours and things like that. I highly recommend reading the book. And then I also just wanted to say that I'm extremely jealous, actually, that I'm not going to be at DevOps Days Amsterdam. A lot of my friends are going to be down there. I had the opportunity to hang out with some of you amazing folks when we were at KubeCon Valencia and got lots of hugs. I got some great socks, so I hope you're bringing them there to Amsterdam. If not, you should. And it's going to be a great conference. So I hope folks who are close get the opportunity to attend.
It's one of those conferences, Julie, where it's still driven by practitioners for practitioners. That's what makes it very nice.
Yeah, that's like I said, I really wish I could have been there. I'm one of the organizers and founders of DevOps Days Boise, and I just love these conferences because they're all so community focused and people are giving their time to speak. They're not being paid. There's nothing like that. And sponsors make it happen. So it's really exciting that you're going to be there and helping to bring this to the community. With that, though, maybe we should talk a little bit about the road to reliability. So I'm going to talk specifically about reliability and chaos engineering and game days. As mentioned, I'm Julie Gunderson. One of the things that I want to talk about is the fact that, look, reliability isn't an accident. And if there's anything we've learned over the years, it's that reliability takes work, and it takes a plan, and it takes strategy, tactical actions, but it also takes teamwork and collaboration. So we want to make our systems more reliable. Now, when I talk about that, you can pick any day and you can search for outage and you're going to find an outage that was impacting. Now, this one, my friend Jason Yee sent over to me, which is just kind of funny because beavers actually caused a power outage or an internet outage in Canada. So oftentimes when I'm talking about outages, they're not necessarily the ones caused by animals, but I just thought this was kind of fun and wanted to share. When we talk about reliability, we have to understand that failures are inherent to complex systems. And our systems keep increasing in complexity. So just for all of you, again, I'm Julie Gunderson. You can find me at Julie_Gund. I am a founder and organizer of DevOps Days Boise, which we just set the dates for next year, and we'll be announcing that soon. Prior to my current role, I was actually at Gremlin, where I talked a lot about reliability, and I really wanted to continue to talk about that. So one of the resources, aside from the zombie apocalypse survival book that I love, is Accelerate. And that's by Dr. Nicole Forsgren. She's a PhD and responsible for the DORA report. It's also by Gene Kim, who wrote the Phoenix Project, and Jez Humble. So this is a great resource. If you haven't checked it out, I highly recommend that you do. Let's see if I can manage to copy a link into the chat for all of you to find this. That should get you over to the book. But they have done an amazing job collecting all of the research they gathered from practicing DevOps over the years. And they also created the DevOps survey and report, the one that Puppet would send out. And what they did in this book is they took 4 years of research and they came together to analyze the data in a great way and bubble it up and say, okay, so these are the most important things you need to do to create a high-performing technology organization and to build and scale high-performing teams. And in Accelerate, they focus a lot on tempo and stability. And a lot of times when we talk about chaos engineering and measuring the ROI of that, folks want to know, well, how do you measure? How do you measure chaos engineering? How do you make sure that you are doing the right thing when you're actually doing this type of work? And how do you prove that the work that you did actually makes a difference and is able to move the needle, especially if you have a lot of different people doing different projects? And it's really important to be able to measure back. And we do this a lot in everything that we do, right? We want to measure back. We want to say, this is how we move the needle, specifically when we're talking about reliability. This is the return on investment we got from doing this work. And over the years, a lot of research has been conducted. A lot of books have been written on how to improve resilience. So I want to talk about two of the practices, chaos engineering and GameDays, give you some practical tips that you can put into action and look at, resource consumption or capacity planning or decoupling services. So let's go ahead and talk a little bit about tempo and stability. So tempo is measured by deployment frequency and change lead time, where stability is measured by mean time to recover, so MTTR and change failure rate. And if we break it down even further, deployment frequency would be that rate that software is deployed to production, like say of an app store. So is it deployed within a range of multiple times a day to maybe a really long deployment frequency like once a year? And when we talk about tempo would be the change lead time. So the time that it takes to go from a customer making a request. So, let's say that customer has a feature request, and it's that time it takes from that customer making that request to that feature being built and rolled out to where the customer can use it. And then stability is our mean time to recover. So it's the mean time it takes a company to recover from downtime of their software. And then we look at stability, change failure rate. So that's the likelihood of defect changes. If you roll out 5 changes, how many of those might have a defect? How many of those might you need to roll back, or might you need to apply a patch for? So is that 1 out of 5 or 2 out of 5? Now, these are the types of metrics that Accelerate recommends that you measure. So let's go ahead and go back to the key practices. So as I mentioned, some of the key practices are chaos engineering and GameDays. And there are other key practices. These are just the ones that I wanted to focus on. So according to Accelerate, you should focus on improving reliability because it's the foundation that enables you to have a really great tempo. It enables you to improve developer velocity, which makes so much sense. But what's really nice is they're actually backing this data up with years of research. And look, we know that engineers feel more confident when software is reliable. They feel more confident to write new code, and they feel more confident that their features that they're building are going to work well. And they understand all the different failure modes because they've been focusing on reliability and they've been trying to improve reliability. And so that makes you actually able to ship code faster and more reliably. And it's really exciting when you can ship new features that work, that you can trust, new features that meet requirements. And so in Accelerate, they say that we should build systems that are designed to be deployed easily and can detect and tolerate failures and can have various components of the system updated independently. And that's a lot of different things that are really great to work towards. So I want to focus on the detecting and tolerating failures specifically. So what's the best way to know if our systems can detect and tolerate failures? I mean, I think we can probably all guess, but it is chaos engineering. And when we talk about chaos engineering, chaos is really a misnomer, right? We're really simulating the chaos of the real world in a controlled environment. So just to kind of give a breakdown for those who aren't familiar with this, chaos engineering is methodical and scientific. So you're starting with a hypothesis, and then you're experimenting to validate that hypothesis. So you're not just randomly going into a data center and pulling out cords like was done in the very, very early days. This is very methodical what we're doing. You also want to start with the smallest increment that's going to yield a signal, and you move safely from small scale to large scale tests, and you move safely from development to staging to production. And communication is important. So you share your plans with everyone. Chaos engineering, these practices are not about catching people off guard. I'm not trying to see if Teresa is paying attention or if Jamie's drinking too much beer and not answering the page. We're communicating. We're sharing the plans with everybody. They understand that we're going to have experiments going on. We want to understand, like, what if there is an incident? We don't want to negatively affect other teams. So we also share what we learned, because chaos engineering is about learning, and sharing what you learn makes everyone better engineers. Actually, when we talk about DevOps Days, this is all about sharing and helping people become better. And we want those practices as well when we talk about chaos engineering. So you want to share internally and externally if possible. There's actually a chaos engineering Slack, which is chaosengineering.slack.com. That's a great online resource where engineers from all over the place are talking about chaos engineering experiments they're running, looking for mentorship, sharing best practices. So I highly recommend checking that out. Chaos engineering is also about iteration. So you create a hypothesis, you run your experiment, you create tasks to improve your software and maybe your processes, and then you update your hypothesis and you repeat. And then you increased your blast radius, and then you keep repeating. So to sum it up, this is what chaos engineering is. It's thoughtful and planned experiments that are designed to reveal weaknesses in our systems, both technical and human. And we want to talk about, where is our tech broken or insufficient? You know, where does that user experience break? Does our monitoring and alerting work? How about auto scaling? Let's validate that. Retries or circuit breakers. You know, we want to look at where our human systems or processes broken or ill-equipped. Like, again, I'm not testing, Teresa. I'm not trying to surprise her or catch her off guard, but I do want to see, you know, is our alert rotation working? Is our escalation process working? You know, do we have the right documentation and playbooks? These are all things that we want to look at when we're talking about chaos engineering. And a lot of people are like, oh, I have so much chaos in our systems right now. It's too scary. We can't do it. Well, first of all, we want to remove the chaos from our systems. That's why we're doing this, so that we can have these controlled experiments, because it's way better to practice something at 2 o'clock on a Tuesday, you know, after lunch, we're all coffeeed up, versus 2 a.m. on a Saturday when we're not prepared. We're building that muscle memory. We're building those skills. So now is the best time, because our systems also become more complex over time. So we want to start when things are less complex. Real quickly, there is a question about Q&A. So there isn't going to be time, but you can find me on Twitter at Julie_Gund, and you can definitely ask all the questions you'd like over there. And I'm also in that chaos engineering Slack channel. So you can find me there. But kind of back to the presentation. So let's talk about, how do we apply the scientific method to chaos engineering? Well, to measure how systems change during an experiment, it's important to understand how they behave now. And it involves collecting relevant metrics from target systems under normal load, because that provides a baseline for comparison. So using that data, then you can measure exactly how much our systems change in response to an experiment. And listen, if you don't have baseline metrics, that's okay. You can start now, and you can actually use chaos engineering to validate some of those metrics. Don't let something like that get in your way to stop you from practicing chaos engineering. And you can actually even practice this as thought experiments with some tabletop experiments, where you just talk through some of your hypotheses and what you think will happen. So one of the most powerful questions in chaos engineering is, does this work the way I think it does? So, you know, once you've got an idea of how you think your system will work, think about how you're going to validate it. So what type of failure could you inject to help prove or disprove your hypothesis? What happens if your systems don't respond the way you expected? So, you know, you've chosen this failure to simulate, this failure to inject. Well, what happens next? And that's a thought exercise to work through as the team, because by discussing that scenario, you can hypothesize on what the expected outcome is when running in production, and what will be the impact to customers, to our service, to our dependencies. And then once you have this hypothesis, you want to determine which metrics to measure in order to verify or disprove that hypothesis. And when we talk about metrics, it's good to have a key performance metrics that correlates to customer success. So when we talk about Netflix, for example, their metric is famously stream starts per second. So as a rule of thumb, if you ever see an impact to these metrics, you want to halt the experiment immediately. Chaos engineering is about making our customer experience better. not worse. So now you've formed your hypothesis, and you want to now look at how you can minimize your blast radius prior to your experiment. So when we talk about blast radius, it's the subset of a system that can be impacted by an attack. So the worst case impact of a failed experiment, and this is measured best in customer impact, like 10% of customers could be impacted, but it could be expressed in hosts or services or other discrete parts of a customer's infrastructure. So when running chaos experiments, it's recommended to run the smallest version possible. And you're going to hear me say this again, but you want to limit that blast radius, and then you scale larger over time. You want to start with the smallest possible experiment to test your system and then expand. And you always want to have a backup plan in case things go wrong, but you have to accept that sometimes even the backup plan can fail. So talk through how you're going to revert the impact. Make sure that you have safety built in and that you can revert that immediately, that you can abort your experiment and return to a steady state if things go wrong. So when you are planning these, you want to have that clearly laid out and communicated with the team so that people understand what we're measuring, what we're looking at, and how we're going to stop that experiment if something goes wrong. Now, after you've run your first experiment, hopefully there's going to be one of two outcomes. So either you verified that your system is resilient to the failure you introduced, or you found a problem and you need to fix it. And when you look at this, both of these are great outcomes, because on one hand, you've increased your confidence in the system and its behavior, or on the other hand, you found a problem before it caused an outage. Now, again, we can't make sure that beavers don't cause all of the internet to go down. That probably wasn't the best one to use to kick off, but again, it was kind of fun. But if there is a way to prevent beavers from causing the internet to go down, that would be great. Maybe you found that out in your chaos engineering experiments, but whatever it is that you found, you want to document the experiment and the results of that experiment, and then work to remediate these situations that you have found. And as I mentioned, a key outcome of chaos engineering is learning. So through these experiments, you're learning about your systems, you're validating your hypotheses, you're teaching your teammates. So share these results, because it's going to help other teams understand how to run their own experiments and where weaknesses in their systems are. And I'll talk a little bit about that with GameDays. So let's just do a quick, how do you get started? So remember, I've talked about this a couple of times with the blast radius. Start small. Be careful. Start with a single service or host, not the whole application or fleet. Start in a controlled environment with a team that's ready, prepared, they know what's going on, and then expand. You can adopt the practice in development so that engineers are architecting for failure. Get confident testing in development, and then move to staging and start small in staging, then expand your blast radius. Then finally move to production, and remember, start small and increase. And look, this is similar to how you do development. You don't need to overthink it. You want to work iteratively like we do with code, move up the environments like with code. We really know how to do this. It's just unfortunately named. So I want to show you a dependency demo right now so that you can kind of see what this actually can look like. So this is a really cool open source project. You can actually find it on the Google Cloud Platform GitHub webpage, and it's a repo called the Bank of Anthos. So check it out. This is the architecture diagram. And this is really great for learning how to practice chaos engineering because it's an internet banking application. It has multiple languages, so both Python and Java, which is really common these days. If you're working on a system, there's often multiple languages. Then there's two databases. There's an accounts database, a ledger database, and these are running on Postgres. And then we have our transaction history service, a balance reader service, the ledger writer, contacts user service, our front end, and a load generator. So this is what it looks like. So take a minute to look at this. And then as we think about our chaos engineering experiments, one of the questions we want to ask ourselves when we start practicing, remember, is what is our hypothesis? So we want to think through what's going to happen. So we have an experiment called a black hole experiment. When I worked at Gremlin, we had an experiment called that. They still do. Anyway, so we want to think through, like, does black holing a critical path service like the balance reader result in a graceful degradation of the customer experience. And so if you want, share in the chat, what do you think if we make this balance reader unavailable, so we make it unreachable, which is what a black hole experiment is, as I mentioned, it's a gremlin specific attack. If we make it unavailable, what will occur to the application? So if anybody has any ideas, just guess in the chat, what do you think is going to happen? You know, will we still be able to use the website? Will we still see what the balance is? Will we be able to deposit funds? These are questions that we should ask ourselves. And my guess would be that if we black hole the balance reader service, I think we might see an error message like unable to read the balance. We might get a user-friendly message. You know, we would also hope that we'd get like a loading, you know, there's some type of issue with the balance reader service that's no longer available, or maybe it was just really well built and we could just fail over automatically. You know, maybe it's one of those services that was unavailable because it was running on Kubernetes. You know, maybe there's going to be some redundancy and we'll actually be able to fail over. So when we take a look at that, so this is in Gremlin, you can select the balance reader service. And again, this applies to whatever tool that you're using. I just wanted to give a great way for people to just visualize it. So in here, we're selecting Kubernetes as a replica set, right? And we can already learn a lot here just from the visualization, because we can see within the UI that there's only one pod that is impacted. So when we talk about blast radius, if there's only one pod impacted and I'm running a black hole on that, that is 100% blast radius experiment. So do not start like this. But if there were multiple pods within the balance reader service, we'd actually see, you know, 2 pods impacted. So that shows us already that when we run this experiment, we're going to make all of the balance reader service unavailable because there's no secondary pod. And this is what it looks like when we run our experiment. Teresa, are you asking a question?
Yes, sorry to interrupt the flow. Would you be able to make the screen a bit bigger
You know,
by any chance? If not, sorry. But
I don't know.
the-
I don't know how to. I'm sharing the Chrome application, and let me try something.
the screenshots are a little bit too small to see what is on them.
Let me hold on. Let me see.
Sorry.
No, I apologize to all of you. As I mentioned, my child stole my office, which is great. He's a good kid. We like him. And I'm using his gaming setup, which I don't really. Okay, hold on. We're gonna try this one more time. Look, I'd like to make some sort of experimentation comment about it, but I don't think I can. Let me see here. Oh, I wonder if this is going to be better if I don't do it in full screen. What is that better, folks?
I think it is.
Yes.
Yeah.
Much better for us. Yes.
All right, and
Thank
you can't see the unicorn running behind it that my sweet child set as a screensaver that is pooping rainbows, correct?
We cannot. No.
Okay, that's great. Just to let you know, there is a unicorn running behind my screen, pooping rainbows. It's amazing. Happy Thursday. Okay, so when we are going through our experiment, remember we've black holed that balance reader service. So look, we can see that the user is still able to make a deposit of $1,000 while the balance reader is in a black hole. And you can see this in the transaction history, right? You can see that we're able to make that deposit. So we've added money to our bank account and we get a successful message, but we still have this dash, dash, dash. We get the successful message. Wow, I don't know what I just did there. So let me try to get back to where I need to be really quickly. I can't use, I also only really know how to use a Mac anymore. And so I'm using a normal mouse. It's very confusing. Just one moment. If anybody has some great zombie facts that they want to share right now, that would be excellent.
I was about to say that this chaos wasn't planned, like the chaos engineering that you were describing.
I know normally I can make some sort of joke about, oh yeah, it's all chaos, but It's too early in the morning here yet. All right, are we back?
We are.
Yay.
Okay, so I'm not going to use my mouse to point over there anymore. That was a failed experiment. So look, if we see the dash, 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 that can be really confusing for a user, right? We've deposited this money. Actually, I think that I want to make sure I got to the right. Okay, so we see the dash, dash, dash. That's what I was talking about there. If I was building this as a real internet banking app for a bank, they'd be like, no way. We would get so many support tickets if this really happened. I mean, this isn't even a real error message, this dash, dash, dash. This could make a user really confused and they might start calling the call center. So if we think about that, that increases the cost of having to answer all those calls. But there could be a lot of problems. I mean, think about it. These users might go tweet about it. They can easily go switch banks. There's a lot of downstream effects that can happen. So we always want to think through what that customer experience is like. But let's check out other functionality too. Like, how does this affect other dependencies? So the user is still able to make that deposit of $1,000 while that balance reader service is in a black hole. And as I mentioned, you can see that in the transaction history that we got that money added to our account. But if we try to make a payment, we're unable to do it. And then we get this message and it's an engineering friendly error message, but it's not a generally friendly customer facing message. So what do you think your friends or your family who don't work in tech, are they going to know what this means, or are they going to call you and ask? Because I promise you, my mother calls me anytime Facebook or Hulu or Netflix. If it doesn't work, she calls me and she thinks that I can fix it because I work in tech. And we want to think about that. Think through the experiences for our mothers, our fathers, our whoever are using these tools, because again, we don't want to have to be answering those calls all the time. I can't fix Hulu. I do not work there. I'm just sharing. Neither can I fix Netflix. I've told my mom this. She doesn't seem to understand it, but she's great. So it's okay. But I've seen errors like this before. I actually still see errors like this on my current bank. It's just that I'm too lazy to change all of my payment methods. And I keep saying I'm going to change my bank, but I don't, because there's all the things that we need to do to change our error messages. But it's very frustrating and it makes me want to change my bank. And if people aren't as lazy as I am, they will go to a competitor. So think about that whole experience of reliability. How does the user see this issue? How do we represent problems to them? Do they notice that there is a problem? Or is there a way to hide that problem from the user and gracefully degrade? Maybe if it's possible, can we remove the component from a web page if it's not working at the moment? There's a lot of things that you can do to allow for graceful degradation that makes a better user experience. And we want to think about that because there have been times when we've all experienced issues, maybe it was with our cloud providers or the different errors that we've gotten. And we want to think about those types of messages, and do they allow us to understand the problem more? Do they make our lives easier, or do these error messages actually cause more stress on the users? So if you're interested in learning more, you can check out this free demo. I'm going to get this link here copied into the chat. I'm going to attempt to copy this link into the chat here. If I can find the chat, which now I can't find the chat. There it is. Let's see if I managed to do that correctly. No, I did not. And I clicked on the link. So now we're going to copy the link here. And I'm going to paste that into the chat. Wait, I didn't copy it. Whatever. I'll get the link sent out. I, again, do not know how to use this computer of my child's. There it is. Look at that. We have accomplished something big today. So here's how you can get this and you can try it yourself. Now, another interesting to look at is different types of failure modes. So let's take a look at the transaction history service and see how a black hole might impact that. So this is the transaction history right here. So you can see what it looks like when things are good. You can see the credits and the debits. You can see who made the transactions. So now we want to see, are we going to get a graceful degradation of this service if it's made unavailable or not? So during our experiment, we've kicked that off. We can see that the transaction history, it's not there. And we get an error that says could not load transactions. But we can also see that our deposit was successful. So at least this is better than the balance reader, and we're not getting a dash, 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 and we have more of a user-friendly experience that doesn't talk about get. And so when we talk about how can we mitigate against a black hole, against something like this when a service is unavailable, well, before, if you remember on the balance reader, there was only one pod. So now we're going to make it 2. We're going to scale replicas. And so we can run the command, kubectl scale deployment transaction history and give it 2 replicas instead of just 1. And so we'll do this for the transaction history for this example. So we'll run the command, and now we can look in terminal and we can see kubectl get pods. And yep, we have 2 pods that are now running for the transaction history to be able to show us that data. So we can do a smaller blast radius chaos engineering experiment. So let's send 50% of the transaction history pods into a black hole. So just one of the 2. So you can see in the bottom on the right, it's 50%. It's one of the 2 pods impacted. So I've selected the transaction history replica set. You can see the 2 pods. There are 2 little green pods in the visualization. So now what's our hypothesis? What can we guess will happen if we send one of the transaction pods into a black hole? Will we get an error message? Will things be okay? Will they get worse? And the interesting thing here is that you never know until you run the experiment. You're never going to be able to guess exactly because it's really hard to do. So if we go back and we look at that architecture diagram, you can really visualize and understand what is happening here. So we have our 2 transaction history pods, we have the 2 replicas, and what actually happens is that there will be a very short outage, not even visible to the human eye, and the other pod's going to take over. It's going to say this pod is not reachable. I'm going to flip over to the other pod. And that is what occurs when we tested this out with Gremlin, which is great because there was no error message. The user was just able to get their data. They were able to see all the transaction history. There were no error messages. So it's a really great way to fail over that service. So now that I've talked a little bit about chaos engineering, I just want to touch on game days. So game days are, again, one of those key practices to help us build more reliable systems. And game days go beyond that too. They're a really great team building exercise. And this is something that Accelerate talks about in the book. Game days are a way to build relationships within an organization, and it's a cultural must-do to become a high-performing organization. And this is so true because they not only help you improve stability and reliability, but also definitely tempo, because it enables you to work closely with other teams that you have better relations so that you can build those relationships, especially if you're a larger engineering organization. So as I mentioned before, one of the great things that comes out of these experiments is, oh, my video is off. Thank you very much. One of the great things that comes out of these experiments is learning. And when you're successful at doing something, it's great if you can bring other people in and help them to learn and help them to also build up those skills. And you can do that with game days as well. So the goal of a game day is cooperative, proactive testing of our systems to enhance reliability. So by getting the team together and thinking through your system architecture together, you can test hypotheses. You can evaluate if your systems are resilient to various kinds of failures. And if they're not resilient to those, you can fix them before these weaknesses impact customers. And so this is just an example of a game day. So what you want to do with a game day, first of all, it doesn't have to be an entire day. We can do game days in like an hour. You can make game days a huge thing, but please do not get intimidated by the word day in it, because game days do not have to be, again, an entire day. So what you would want to do is you'd want to invite 4 or more people to attend a game day. And it's good to have at least 2 teams, but you can invite more because you want to know if you have some type of failure, how does that appear to the other team? Or if they have some sort of failure, how would you see, you want to see how that affects your system. And that's why these are so great. You're doing this in real time. They're not happening at an incident. Remember, you're doing it at 2 on a Tuesday with coffee and a Zoom, not 2 a.m. on a Saturday morning after a bunch of Stella beers. So again, you don't have to spend hours doing this. When I worked at PagerDuty, we had something called Failure Fridays. We did this on Fridays after lunch. We spent an hour running our game days. So you should at least plan for an hour, but a minimum of 30 minutes. And oftentimes we see folks spike load, maybe using Gatling or JMeter, and then they introduce different types of failure modes within their chaos engineering tool. So for example, if you use JMeter, you could be like, all right, let's send a bunch of requests, but now I'm also going to spike CPU because our auto scaling is based on CPU, or maybe it's based on a mix of CPU and requests. So this allows you to create a situation where auto scaling should occur, and then you can see that it works, and that when traffic subsides and the CPU attack finishes, you can see that it's going to go back to normal and it'll scale back down. So you can run one of these experiments for 60 seconds, for example. And this also helps you think through other things, like thinking through cost management with cloud infrastructure, right? Because we want to keep costs low. And a lot of SREs really care about that too. How can I say we saved, this much money, or we were able to make sure that we were able to quickly scale down when we don't need to be running a large number of machines in our fleets. So that's one of the other things that we can actually test, as I mentioned, with our experiments and with game days. So how to plan a game day, 30 minutes to 1 hour sessions. 2+ teams. You want to decide on a communication tool. Is that Slack or Confluence? Is it a doc? Ideally, it's not email. Hopefully, you're not sending emails back and forth with each other. But if you do, and that works for you, that's great. So you want to plan and design, 2 to 3 use cases. But as I did here with you, review that target application architecture. Decide on what that blast radius, is, and that scope is. What do we think is going to happen? Create that hypothesis, but also make sure to identify those abort conditions and make sure those tie back to the customer experience. You want to assign roles so that we know what folks are doing. I know what Carl is doing, or Jamie, or Teresa. Maybe somebody's the one running the experiments. Somebody might be observing the experiments. Document those results and share those results widely in the organization. And if you can share them externally, like at a conference, if you can talk about how you've made your systems more reliable, do it. Let's teach others and make sure that they're not afraid of these types of things. So here's some other examples of game days. You can do dependency testing, capacity plan testing, auto scaling testing, as I mentioned. Now capacity planning is an interesting one. So we've seen outages when folks tried to scale up during a peak traffic day, and they actually didn't have the limits set correctly. They weren't even allowed to do that. They didn't have the permissions set up, and there were caps, and they just couldn't scale. And that's a really bad situation. And you definitely want to test that your caps are not in place in a bad way that impacts you. So we want to make sure that we understand all of these things. Now, here is a scenario planning template. You can actually find this one at gremlin.com/game-days. So this gives you the opportunity to, document what's your attack target, your attack type, what failure condition are we going to simulate? And one of the great things to simulate too is if you had a failure that you remediated, let's go ahead and go back and simulate that. Let's make sure that as we're doing this, we don't drift back into failure. What was the expected behavior and risk, and what was the post-attack state or impact? And then one of the questions that we get a lot is, can I automate this? And yes, you can totally automate this. And, we absolutely recommend, codify your chaos engineering experiments. You want to make them shareable. You can do version control. You can show the history of your experiments. You want to save them. Have a wiki where you can have all of that documentation there. So within Gremlin, there's some great ways to do that. And if you're in that tool, you can use scenarios, but whatever tool that you're using, you do want to make sure that you automate these and that you codify them. And you want to do this for production readiness, especially when you're integrating your chaos engineering experiments into your CI/CD pipelines. You might say, you need to pass this number of chaos engineering reliability experiments that pass through these before you can ship your new service to production or before you can ship your change. If you're going multi-cloud, you want to make sure that all the code can pass through these experiments. And come on, we all know that lift and shift isn't really a thing or a thing that works out well all the time because environments are so different and there's a lot of fine-grained detail. So you want to help automate this so you don't have to go around teaching everyone the SRE best practices. You can just build a system that can go in and quickly and check that you're giving people the right tips so that they can do better work moving forward. So with that, I just want to let you all know that, again, you can find me on Twitter at Julie_Gund if you have any questions that I can help with. And don't forget, chaos engineering, it's not scary. It's just unfortunately named. And it looks like I have 3 minutes. So Jamie, was there anything else you wanted to share?
No, thank you. I love that. Chaos engineering is not scary. Loved it.
It isn't. It's okay. When I was at PagerDuty, we actually had a podcast, Page It to the Limit. One of the first episodes was with Bruce Wong, where we talked about tabletop experiments on chaos engineering. So if that is something that you're interested in learning before you actually touch your systems, you can definitely go check out that podcast. And with that, again, feel free to hit me up with questions on Twitter or in the Chaos Engineering Slack, which is chaosengineering.slack.com. And we will make sure to get a copy of the slides out.
Thank you so much. I think that all that is left to say is, number one, I'm a little bit drunk now, a bit tipsy. Number one, that's not relevant to the webinar, I'm just saying. Number two, thank you, Julie, for an amazing talk. So I think we need to give Julie a round of applause, everybody. This is what we do at Container Solutions. We clap on events. We also sing happy birthday to each other. That's a bit weird on a call with 100 people. Of course, follow the links in. Yeah, beware the zombies for sure. Beware the zombie apocalypse. And think about changing your cloud provider, because I think that we should be covered in the event of the zombie apocalypse. Get to DevOps Days next week if you want. Follow the links in the chat box if you'd like to know more about the events that we're holding, etc., etc. Hit up Julie on Twitter if you've got any questions for her. And unless there's any final words from Teresa or Carla or Julie, there are no final words, then that just leaves me to say, welcome back everybody to this WTF. I can't wait to see you on the next one. Thanks to Emin, the gossip. Thanks to Julian. Thanks to Carla and Teresa who put all of this together. Thanks to Julie, our guest of honor. Thanks to all you participants. We will see you next time. Bye.
Thank you so much, Julian. Thank you.